So far we've seen standard form, which is what you're probably most familiar with, and vertex form, and we just did an example on how to switch from standard form to vertex form. We're going to look at another equation in standard form right now, and we're going to put it in vertex form, but we're also going to put it in something called intercept form. I'm going to leave that blank for a second, and we'll come back and fill in what intercept form is after we do this problem. So the equation in standard form says y equals negative x squared plus 2x plus 8. Let's do the work to get this into vertex form, and then we'll talk about what it looks like in intercept form. Remember that we need to complete the square, and to do that, we need to separate out these two terms from the constant term in the back, and then factor out this non-positive 1 coefficient. So I factored out a negative 1, okay? And if I multiplied this back through, notice that we would get negative x squared plus 2x. So y equals negative 1 times the quantity x squared minus 2x plus some unknown thing we're going to add in, plus 8, and then we're going to have to put something in the back here to compensate for whatever we add in to make a perfect square trinomial. So remember, we take this number, divide it by 2, and square it. So negative 2 divided by 2 is negative 1, and negative 1 squared is positive 1. So we added 1 inside the parentheses, and remembering that to compensate for that, we need to figure out what we really added by multiplying this coefficient through. So negative 1 times positive 1, we really actually just subtracted 1, right? Because this whole thing says negative x squared plus 2x minus 1. So we really just subtracted 1, so we need to add 1 out back. That means we have negative 1 times some binomial squared. That's what we did with completing the square. We know now that we can write this as x minus 1 times x minus 1, and then 8 plus 1 is 9. So in vertex form, this is negative x minus 1 quantity squared plus 9, right? And that negative 1 I can either write as just a negative or as negative 1. So that's vertex form of the original standard form equation, y equals negative x squared plus 2x plus 8. Let's take a quick look at the graph of this equation, using both the standard form and vertex form to help us get an idea of where some points are. Vertex form, of course, allows us to see that the vertex is at 1, 9. So at 1, 9, we have the vertex. We also know that because it has a negative coefficient out front, that this is going to open down. Using standard form, if I plug in 0, that's going to be y equals negative 0 squared plus 2 times 0 plus 8. Okay, so this 8 here is going to be our y-intercept. So there's a point at 0, 8, and because of our axis of symmetry through here, we know that there's a point at 2, 8. Let's plug in a couple other points and see what we get. Let's plug in negative 1 and negative 2, and then also positive 3 and positive 4. I'm branching out sort of to the left of the points I already know and to the right. Plugging negative 1 into either form is going to get 5 for our y value. Plugging in negative 2 will get us 0. Plugging in 3 will also get us 5, and plugging in 4 will also get us 0. Remember, it makes sense that we're getting the same y values because of the symmetry of a parabola. So we have a point at negative 1, 5, and then we have a point at negative 2, 0. On the right, we have a point at 3, 5, and a point at 4, 0. So our parabola opens down from that vertex of 1, 9, has a y-intercept at 0, 8, and it has these x-intercepts at 4, 0, and negative 2, 0. Those are our x-intercepts, and that it's what's going to determine intercept form. Rather than just plugging in and randomly figuring out where we get a y value of 0, okay, that's where the x-intercepts are, we can use what we know about quadratics, specifically about factoring them, to put it in what we call intercept form. So if I take the standard form equation, y equals negative x squared plus 2x plus 8, and all I ask myself to do is factor it, we'll be able to find the intercepts. So the first thing I'm going to factor out is this negative, and then I can just work with the quadratic in parentheses and use some of my typical factoring rules. I need two numbers that multiply to negative 8 but add to negative 2. let's see, so negative 8 and positive 1, that doesn't add to negative 2. Negative 4 and positive 2, aha, that does add to negative 2. So y equals negative, right? Remember, I have to keep this negative along with me, that coefficient out front. X minus 4 times x plus 2 would multiply together to be x squared minus 2x minus 8, right? So let's check that quickly by foiling. First, x squared, outer plus 2x, inner minus 4x, and then last, negative 8. And in the middle, we would get negative 2x. So yes, we factored this properly. So this is called intercept form because this value of 4 and this value of 2, okay, tell us where the intercepts are. It tells us what values we would have to plug in for x over here to make y equal to 0. For example, what if we plugged in x equals positive 4? Well, y would equal negative 4 minus 4 times 4 plus 2, right? I've plugged in a 4 for both of the x values. 4 minus 4 comes out to 0. 0 times 6 over here comes out to 0. And it doesn't matter if I make that negative, the whole thing comes out to 0. So here if I plugged in a positive 4, the y value would become 0. And on the right here, if you plugged in a negative 2, the whole thing would become 0. So intercept form tells us where the zeros are, the values of x that would make y 0. So in this case, we got y equals negative x minus 4 times x plus 2. And in general, we call that y equals a, there's that a value, again, every form has an a value in front of it, times x minus p, and then x minus q. Okay, this one is really a minus because we can think about this as x minus negative 2 being where that 0 was. Here, P and Q are the x-intercepts, right? And that's why this thing is called intercept form, because P comma 0 and Q comma 0 are the x-intercepts of the equation.